Hello. Today we'll look at formulas in math. So, formula in mathematics is generally an equation that contains more than one variable. And you are familiar with some of the formulas already. For example, you're familiar with formula for perimeter of a rectangle, right? The perimeter, which is represented by P, is equal to 2L plus 2W. That's a formula, okay? Or you're familiar with the formula for area of a rectangle, right? Area, we know, is the length times the width. So these are the types of formulas what we're talking about in this specific section. Now, to begin to work with formulas, you have sort of done some of this before in the sense that if you were giving a numerical equation, okay, so given, let's say you have 2x minus 3y is equal to 5, okay, and you're asked to find y, okay, when x is equal to negative 3. So generally, if you're given this, you will plug in, we say, or substitute. You will replace the x value with negative 3. Yeah? And when you do this, you tend to simplify this. So now you distribute 2 times negative 3 will be negative 6 minus 3y is equal to 5. And you will add 6 to both sides since we're going across that equal sign. So this becomes 0, plus 6 minus 6 cancels out. So minus 3y is equal to 6 plus 5 is 11. And then to get y by itself, we'll divide both sides by negative 3. So we end up with y is equal to negative 11 thirds. Okay. So this is basically the steps you have been using before if you want to isolate, if you want to solve for y, right? Find y. Now, specifically what I would like to talk about for this section is when do you have a formula, and then we'll look at some examples to see how this works, okay? So, for example, if you were given a formula of some sort, right? Doesn't have to be a formula that you are aware of. There are many different formulas out there. They're the formula for the perimeter of a parallelogram, okay? There's the area of a parallelogram. There's the formula for interest rates, okay? Principal interest, simple interest. There are so many formulas. But suppose now you're given a formula for the area of a rectangle, okay? So, example, solve for L. And you're given A is equal to L times W. Well, solve for L, you know solve for L means to leave L by itself. So in this example, what we have to do is to get rid of that W, okay? Now, if L was a number, let's say 2, okay? If L was a number 2, you will divide both sides by 2 to leave W, right? But now L is not a number, L is a letter, and you want to leave L. So what we'll do, we will divide both sides by W, because the W will cancel out, we say, and we have A over W is equal to L. And this is our answer. We have isolated L. We have left L by itself. Okay? And that's the kind of formulas I want to look at. And then we'll look at some equations to get you into the hang of solving equations a little more. So basically, we'll be working through a bunch of examples here in this section. Okay, example. Okay. How about if I give you A is equal to 1/2 BH? This is the formula for area of a triangle. 1/2 the base times the height. Now, and when we say for B, this here indicates that you should solve for B. So this implies solve for B. That's what it means. So the first thing we're going to do, so basically we have to get rid of the 1/2 and we have to get rid of the H, okay, to leave B by itself. So let's move the 1/2 first, okay. A is equal to 1/2 BH. And to get rid of a fraction, we will multiply by its reciprocal. So if the fraction is 1/2, you flip it. That's the reciprocal, okay? But if I do it on the right side, I also have to do that on the left side. So the 2 and the 2 will cancel, the 1 will cancel, okay? And on this side now, 2 times A is 2A. And if you want to put this over 1, 1 times 1 is 1, so we don't need to write it over 1. And that is now equal to, I should have written black, 2A is equal to BH. And now remember, we're solving for B, so we have to remove the H. So what we do now, we divide both sides. We divide both sides by H. Okay. H will cancel out. So that leaves me with 2A over H is equal to B. Now, I want to point out something to you because in your homework system, this is very important, okay? In math, an uppercase A has a different meaning from a lowercase a, okay? So in this example, notice that A here was uppercase. So you cannot convert this to a lowercase, okay? It must be uppercase throughout the problem. So make sure in your answer you use an uppercase, okay? That is very important. The letters must be the same, okay? Now, here's another example of a formula that you are very aware of or well aware of. Example, y is equal to mx plus b. You should know what that formula is. That is the formula for equation, a linear equation, right? Now, if I want to solve this for x, okay, means leave x by itself. So what do we move first? So here, notice we have to move the m, we have to move the plus b. Now you're aware that when you solve equation, that number next to the letter that you're solving for, that's your last move, right? What I'm trying to say here is if you look at this example, if I ask you to solve y is equal to, or let's not say y, let's say 12 is equal to 2x plus 3, the first thing you'll move is the plus 3. You don't move that 2 until way at the end because you're solving for x. And that's exactly the same idea we'll use over here. First, we will minus b on both sides. Now b and y are different variables, so you just write y minus b, or minus b plus y. And that is now equal to mx. This plus b and this minus b will cancel out. And now we want to leave x by itself. So what we'll do is divide each term by m. Okay? Or you could have write y minus b, everything over m is equal to mx over m. Okay? The reason I like doing it this way is because if there's some simplification, you may be able to see it. So now this m cancels with that m, and you're left with y over m minus b over m is equal to x. Okay? Which is the same, by the way, right, as y minus b over m equals to x. So either one of these two answers are correct. Okay? Any one of them. Let's look at another example. How about if you're given C is 5/9 f minus 32, and you're asked for f. So this is the formula that converts Fahrenheit temperature to Celsius. F stands for the Fahrenheit, and C is the Celsius. Okay? So for example, if today is, I don't know what temperature it is today, let's say maybe 20 something degrees. Right now, let's say 30 degrees. And you want to convert that to Celsius, you could plug in F as 30, simplify this, and see what's the temperature is for Celsius. But our goal is to figure out what Fahrenheit is. Okay? So, similar to what we did before, we could get rid or move the 5/9 first. It doesn't make sense to distribute it, although you could distribute it, but we don't want to create work. So we saw to remove a fraction, we multiply both sides by the reciprocal. So we will multiply both sides by 9 over 5. Yeah. When we do this, we have 9c over 5 is equal to, the 9 will cancel, the 5 will cancel, f minus 32. Our goal was to solve for f, so now we will add 32 to both sides. And once we do this, we have 9 over 5c plus 32 is equal to f, and this will become 0 in the end. So here is our final answer. We could write 9 over 5c. We could put the c in the outside if you want, plus 32 is equal to f. Or you could 9c over 5 plus 32 equals f. Either one of them is correct. Okay. So as you see, that all we're doing here, we're isolating the letter that's asked for. Okay. Let's look at one more example, because this is not a really intense topic, at least for now, because we're not getting to the application part of this. Let's look at this formula. H is equal to Vt minus 16t squared. And we want to solve for V. Okay? We want to solve for V. And here I'll show you why I usually divide as I did up here, every single term. Okay? So There's a couple of ways this problem can be done, at least two ways that I'm seeing, but let's look at a way that we want to make it easy for ourselves. Okay, so the first thing we'll do, we will move the term without the v. So we have h is equal to vt minus 16t squared. I am going to add 16t squared to both sides. And if I do that, we now have h plus 16t squared is equal to vt. This becomes 0. Okay. Remember I said before, whatever is next to the v, that's what we leave for last. So now we can move the t, okay? And if I move that t, okay, we have h plus 16t squared is equal to vt. To move that t, what I said before, we will divide each term by t. When we do this, we have left h over t plus these two t's can be simplified, 16t, because t squared, remember t squared implies t times t, and if you're dividing that by t, one of the t's will cancel out. Okay, equal, this t will cancel v. Okay, now if you had written it the other way, okay, h plus 16t squared everything over t equals vt over t, then you probably wouldn't have done the simplification and your answer wouldn't be fully correct. So this is the final answer that is acceptable, okay? And that's the reason I like to divide each term rather than putting everything over t as I did here. So if you do that, you will still have some work to do, okay? Now, the same thing can be done, okay? The same thing can be done when we have a mathematical equation, okay? If you're given 2x plus 3y equals 6, and you're asked to solve for y, all it means is to leave y by itself. So we'll take the 2x plus 3y equals 6, and we'll minus 2x on both sides. If we do that, this cancels out. We have 3y is equal to minus 2x plus 6. Okay? Now, to leave y by itself, we will divide each term by 3. And when we do this, we have the 3's will cancel out. So we have y is equal to minus 2/3 x plus 2. And here is the equation. Now you will see a lot of these because when you're given an equation with two variables, here we have an equation with two variables, okay? And this is a linear equation because we talked about linear equation and we said that when the exponents are 1 for all the variable, it's linear, right? Or it could be put in the form y equal mx plus b as we did here. So you can tell the slope and you can tell the y-intercept. But we will talk more about this when we get to linear equations and graphing linear equation, which is the next chapter. Okay? Let's look at another equation before we close off this topic. Example, if you're given minus 3x plus 5y equals 15 and you're asked to solve for y. So minus 3x plus 5y is equal to 15. I want to leave y, so what I'll do is move the x first. So I will add 3x to both sides. When we do this, this becomes 0. We have 5y is equal to 3x plus 15. Notice I write the x term first because usually I know this is linear, so it's y equal mx plus b. The x term is first. And now to get y by itself, okay, to leave y by itself, we will divide each term by 5. And when we do this, we have y is equal to 3 over 5x plus 15 divided by 5 is 3. And here is our equation in terms of y. So when we're solving these equations, we may not get a number, a physical number, as what you're accustomed to get when you solve equation. Generally, when you solve equation, you want a number for x, or x equals some number, or y equals some number. And that's not what is happening in these types of formulas, we call them. Okay? So this topic can also lead to solve equations that are in terms of a problem. Okay? A word problem or application problem, as we call it. And we're not going to look at that right now because we have to do some application problems later on anyway. Okay? So we'll get back to application problem in another video. So for now, we'll just stop here with how do you isolate specific letters.